And this is the short version of my project overview. If you remember last year, I took a project that Dr. Fonseca was working on and poured it to a Jupyter Notebooks and Google Labs or Google Colabs. This will allow more people, more researchers particularly, to access it. I added some basic graphs once the output was run. I also added a zipping function, so basically once the code was run, you'd be able to download the results, because since it's on the web, you need to be able to download the tables. Now, why is this project so important to me? Why do I like working on this project so much? Because there are a lot of families and a lot of people that are looking for answers and hopes in new drug development. A lot of providers aren't always sure what's going on with any particular drug at any particular time, so this research can really be impactful in a lot of people's lives. You know, simple questions like, what new trials have been introduced this year? What new drug trials have been completed? What fell out this year? Those are simple questions that should be able to be answered easily. So it's kind of my driving point. Another reason I like this project so much is because I look for projects where I can take what I learn in class and port them to a real life project. Because, you know, we can fight with homework and we can get homework done, but if we never apply those skills, especially to real life projects, and come up with new challenges, then we never grow. We never really retain that information. So this year, one of the problems I was having was the original input data, getting data to it. The current method is we download the data, we expand it to Postgres, so an SQL database, we write some SQL queries, we pull the data out in SQL, and then we reload it into the application, the processor. And I remember when I was trying to figure out a better way, because I thought about automating that particular process, I remember, hey, we learned about APIs. Remember all the problems some of us had getting access to Twitter API? Well, we learned about APIs, so why not try an API? Clinicaltrials.gov has an open source API. I don't know if the open source is the right word, but basically their API, you don't need to sign up. You just send them a query and they send you back the data. It's completely open, it's so easy to use. No registration, no nothing. Also with clinical trials, one of the things is that especially newer protocols, newer methods are requiring more and more researchers to register through clinicaltrials.gov. I was just recently working on a project with IRB, and IRB, UNLV's IRB, literally wanted every research proposal to have a clinical trial number on it, where in the old IRB.net, this wasn't the case. So more and more research is being pushed to clinicaltrials.gov. So having fresh data is becoming more and more vital. So the open API, I thought it was going to be, hey, this is going to be really, really vital, really nice, and I can move on to other bigger projects. However, working with the API created all types of problems for me, but again, those problems allowed me to grow. Here's some of the problems. There was no API wrapper, for example. An API wrapper is just somebody that took the time to basically write a method to call an API. And there was actually one API wrapper. I used some of the code from it, but you couldn't iterate over it. I had to combine two different data frames. We did this, Dr. Fonseca did this in the Bitcoin analogy. There's a lot of things, combining things, dealing with special characters, working with JSON versus CSV. When we take that database class next semester, I'm going to continue this, especially looking at JSON database or JSON data structures. So in my mind, the way I kind of coded this out, this is a really interesting idea, is that I want somebody to be able to type a disease. So ALS, Parkinson's, depression. Just a researcher on a website can type a disease, and they get a quick data pool. With this quick data pool, they can answer some very basic questions. Are there new studies? When are there new studies? Are there closed out studies? What has changed the last couple of years? What states are of interest? So, if I'm looking for a trial, or if I had a question, what states have the most active research in diabetes? That should be able to be answered relatively quickly. So I wrote two different API pools, an API pool for just certain fields, popular fields, and then a full API field. This is a JSON pool, this is a CSV pool. So once you answer your disease, hey, depression, boom. Hey, you know what? It's good enough for me just to know that here's 22 new drugs this year that are introduced for depression. I'm done. I can review the data, move on. I want to do a quick data pull for depression. Let's work through the other logic. And you know what? I want to know on depression, what's the ethnicity, what's the demographics of the people in the new depression studies. Well, this is not in the normal data pool, so I have to do a full data pool. So it kind of, this kind of breaks out. So we have a very fast data pool. We have a little longer data pool. In the other video, I showed that this takes maybe 2 minutes to pull, I don't know, 20,000 some studies. And this one takes probably 10 minutes or so to pull data. So let's run some code. Let's get to it. So this code, this is a basic processor for just a quick and lightweight one. So as you see, it asks for a question up here. So what do I want to search for? Parkinson's. Okay, my imports. This is because I had some memory problem handling, but we fixed that. This is some code that originally was from another person. I'll leave a link later. But basically, his code, the wrapper, didn't include an ability to iterate over multiple studies. So I could pull, so like I said, his code, you could only pull maybe 100 studies. Well, that doesn't work for me. What if I need 3,000 studies? What if I need 20,000 studies? Being able to pull 100 studies total, not at a time, just total, doesn't work. So I added some code and I changed some of his libraries by including this minimum rank, and there's a, right here, minimum rank and maximum rank. There are fields that the API accepted, he just never got around to coding those. So I had to change somebody else's library. I guess it's the first time for that. So you see here, okay, so we just set the disease from the input. We pull fields, the ID, the condition, the title, the brief title, we pull multiple things. We basically take that and throw it into a data frame, and then we append it to a new data frame. There's probably a more elegant way to do this, but this is the only way I can really figure out how to do it. We name the columns, and you see this took 9 seconds. 9 seconds is not bad for Parkinson's. So it pulled 3,662 records in 10 seconds. Here's a sample of some of the records. So it pulled 20 columns, 3,662 records in 9 seconds. And so I did that one basic pull, and then I do another pull here, another CSV pull, and then I basically merge them. We do the same thing on the Bitcoin pull. So I basically just use very similar code, a slightly different type of join, but still. And then I save it to Excel, and I save it to an HDF5 file format, a structured file format. This is more important when I do the JSON. So again, it works very, very beautifully. Here's a JSON one. Now the JSON pull is a little different. It's very similar code. This is all the same. Again, same library I've used, same which I hacked up. Okay, we'll do Parkinson's. Again, 3,600. But instead of listing fields, so before it would say get studies, we had this field. Okay, so let me show you. I'm going to switch back to the other code. Let me scroll up here. So right here. So here's the fields we pull. And it says get study fields. So now we're getting full studies, but we're not pulling fields, so we're pulling all the data. The problem is this data is not structured in CSV format. It's structured in like XML or JSON, it's structured data. Also, well, Parkinson's is not too bad here. I guess I should have commented that out. If you're pulling something 20, 30,000 records, it's important to say, hey, because this one only pulls out 100 at a time. So it's a lot slower process. Yeah, a minute versus 9 seconds. So, you pull, I don't know, 30,000 records, that might be 10 minutes. And it's just good to give the user some feedback. And then, again, at the end of the day, I just dump it in HD5 format. Okay? Now, I put a processor on this. Now, this processor is light years away, and it's so basic compared to Dr. Fonseca's processor. So Dr. Fonseca's processor matches on drugs, on diseases, on classes, on all these beautiful fields, and does so much more beautiful post-processing than this. However, there's a paper, and I can pull it up here real quick. Do I have this paper right here? And basically, I was just trying to kind of duplicate this paper. So this paper says, hey, Parkinson's disease, study type intervention, early, blah, blah, blah. And so I just wanted to kind of duplicate this. However, in the process of duplicating this, the process of validating my data, I found some of their data was incorrect. Okay, so I know that my code and my validation works. Okay, so let's just run this processor right here. Let's clear all outputs and just run it. Okay. So one of the first things we do is change date time thing. So like date, see the word date there, but it's an object. So we can't really search efficiently on that. So let's also add the links too. So I'm adding links and I'm changing the date field to date time, simple stuff. And then I'm adding a data frame mask, which basically just hides the data. So for example, on this, I want all the research in the last year from 2021, January 2021 to December 2021, and it just basically loads it in a mask. And then I can say, hey, let's look at this. So right now I'm showing, I don't know, a few thousand studies without the mask. And when I apply the mask, you see right here, the data frame mask and mask. Okay. You see it's down to a lot less. It's down to like, I don't know, what do we have here? I think 200. Yeah, 233 rows. So this adds up to probably about 233. A little low there. And then, like I said, that study, the last study you saw, was using interventional. It was looking only at intervention. So here's interventions only. So again, I just add another mask and do the same thing. So this processor, again, it's not designed to do anything major, but I just wanted to be able to verify and validate my pulls, my data pulls. And really the only way to do that was to make a basic processor, and then we just save it out to Excel. Okay. And again, I can change the input to say, hey, what would you like it to be named, all that type of stuff. But let me just load this file here. So here is the output of my processor. We have the ID, the condition, the official title, the brief title. So just, the basic stuff. You see, we should only have interventional because we filtered out everything else. But again, my processor is quick enough and easy enough to access that I can say, hey, I want only devices. I want observational studies. Eventually I'll be able to have like a drop-down box with different selections and say, hey, I want this, this, and this. So that's what's really neat. It's just, like I said, a real quick processor. The main goal was to get the API working, to be able to say, hey, right here, this was a goal. To find the input, I want to look at Parkinson's, I want to look at Alzheimer's, I want to look at ALS. Do a quick data pull, okay? I want to know all the ALS studies that started last year. I want to know what state has the most ALS research. I want to know what is it, devices, observational, interventional, what's going on with ALS, okay? What percentage of Parkinson's drugs are registered or reapproved drugs? So this is all a quick data frame. So that would all follow this. But if you want to dive deeper, hey, with Parkinson's, what's a demographical breakdown? With Parkinson's, what is the main PI's name? Or there multiple? Is one PI doing research through multiple diseases? Those would have to use the full API pull, the JSON pull. So again, thank you for your time.